Thank you for having coming to this session. Let me just fire up the slides. So again, welcome back. Welcome to my session. My name is Elkhan Yusubov. I am a cloud architect for a company called T-Rex Solutions, and we are going to have this journey to the cloud. And you would, I hope you'll get some new information, and you can also share some information if there is something that you find very interesting. So a little bit about myself and session is on this slide. So I work for T-Rex Solutions. We are relentlessly driving innovation as a dominant force in government IT modernization. We solve our clients' complex mission critical challenge by utilizing our deep technical expertise with powerful next-gen technology in cloud adoption, cybersecurity, and data analytics. Regarding this session, we are going to focus on Azure Cosmos DB. And without any extra words, let's start it. So what we will cover in this session, we'll start first with Cosmos DB, what it is, why Cosmos DB and what makes it special. Then we'll look at managed databases that are introduced under the cover of Cosmos DB as an engine. And then we'll look at consistency models that it introduces. Then we'll move toward configuration and see what type of configurations are readily available. And we'll actually provision one through Azure Portal. Then we will look into development tools and how to leverage Microsoft development tools that are going to save time and honestly some credits to understand how to develop against Azure Cosmos DB or any storage account that's currently we have in Azure. Then we'll look at some demos. We'll have some demo applications built on .NET Core that are going to utilize either the Azure Cosmos DB or locally running Cosmos DB emulator to see how it can interact. And then we'll look at security considerations while we are setting our Cosmos DB in the cloud. What are the good practices and best practices, and what to have in place before starting. Okay, so this is the main point to cover for today's demo. But even before I start these sessions, if you want to put just couple sentences in the chat about, what type of experience you have with Cosmos DB, did you had any chance to run it as a developer, or did you already have that for your production app? That would really help me to shape up this presentation and also connect with you. So let's start with the first topic, which is what is Cosmos DB? Okay, so Cosmos DB is in a wide, broad thing. You can look at it as an umbrella of engine, which is providing different types of data models, which they call multimodal, for the consumption. And in other words, basically a fully managed database service, which comes with the turnkey global distribution, where if you want to make a geo distribution, it's actually built in. You just need to enable that and then set up your geo distribution, which I will show in the demo. Then it actually comes with single-digit millisecond read and write latency guarantees on 99 percentile. And this is one of the few, maybe even like only the database in the cloud that comes with SLAs that actually backed all this performance and single-digit millisecond read and writes. In addition to that, it has well-defined 5 consistency choices. And as you know, in terms of databases, there are strongly consistent or there is eventually consistent database, but Azure Cosmos DB comes with 5 of them, and we'll look at each of them. So in terms of elasticity and unlimited scalability, it also comes with a lot of ease to use, meaning that once it is provisioned and you provide enough capacity, then it's going to basically automatically scale. And let's move to the next slide. So we talked about managed database, what it is. So under the umbrella of Cosmos DB, you have multiple managed databases that you can provision at the point when you are creating them. And it, roughly speaking, it's actually it is divided into 4 categories. And what they are is these 4 categories that you see. You start with the key value pair, which is basically something that you may be familiar with while using this Redis cache. Then you have column family type of databases that supports, which is like Cassandra. And then you have document database, which is something that MongoDB or SQL API is supporting. And you have a graph database, which is Gremlin, that gives you these nodes and connections. And if you have some data model that's based on the relationships and you want to see connections between, and there are some vertices, then you can go with that. But in terms of managed database, the biggest advantage is that the ongoing maintenance, as well as replications, scale replications, as well as most of the database backups, they are taken care of for you. And on top here, you see each of them, like SQL API, Table API, MongoDB API, and Cassandra and others. Okay, so next is, okay, so
yeah, we cannot see the slides.
You don't see the slides? Oh, sorry. Let me make sure that I'm sharing the screen. That was okay. Sorry, do you see the screens now?
Yes, we see it now.
Please let me know if you see the screen. So I was actually
we were able to see in the beginning for just a few minutes, and after that they dropped. So we can see
okay.
them. Hi, Elkhan, can you hear us? Hello? Hello, can you hear me, Elkhan? Could anyone in the meeting hear me?
Yes, I can hear you.
You can, but Elkhan, I think he has some problems now with he dropped.
Yeah.
Okay. Just for all of you to know, I think he will be back. Probably when changing the screen, something happened with his connections. Just for all of you to know, probably you noticed this is a recording sessions because we want to share after that with everyone. So let's give him a minute. Give us that 1 second. I'm trying to see exactly what's going on with Elkhan connections, and I'll let everyone know in a minute. Thank you.
Hello, everyone. Can you hear me?
Yes, we can hear you now.
Yeah, I lost actually connection. My Teams went bad. I don't know what exactly happened, but I'm back. Okay, so sorry for inconvenience.
Perfect.
Yeah, just to make sure. So
Happy
I'm
to
going
have you
to
back.
share my PowerPoint again. Sorry for that technical issue. It was not, something that I. Okay. All right, so I'm sharing my screen now. We're trying to. All right, let me know once you see the screen. Where you should see the.
Not yet. Not yet.
Not yet. Let me know, please, when you. Okay, you should be able to see it now. Where it shows. Okay, let me know when it is there.
Yes, we can see it. Thank you.
Great.
Thank you.
Okay, thank you. So where I was is we spoke about the agenda, which was about these 8 points that I'm going to present about, which is what's Cosmos DB, what are the managed databases there, what are the consistency models, configurations, development tools, demo, security considerations, and onboarding best practices. So we started with what is Cosmos DB, and we say that it's basically an engine that actually powers multimodal databases that are provisioned at the point when you are creating the instance, and it comes with SLAs, which is service level agreements, where they back the performance by 4 nines or 5 nines based on how you provision that. And these geo distributions provide that 5 nines, which is basically the best you can get currently with cloud databases. Now, going next, I described this key value, column value, and documents and graph models that you may have with these databases, where key value part is more or less reference to the Redis cache type of databases, and column value is more or less defines the model that Cassandra is using. For documents database, there's like Mongo API as well as the SQL API are using that data model. And we have graph where you have Kremlin that does databases. So in terms of databases, what it is, so there's this big name Cosmos database, but is there a database in Cosmos? Now let's learn about that. But before jumping into the Azure portal and looking how to provision one, we are going briefly look at the consistency models. So in terms of consistency models in any database that we deal, we actually have mostly two models, which is the strong consistency model or eventual. And difference is that if you want to have, if you are using something like, a traditional RDBMS, relational SQL database, then there you have these strong consistencies. But when you use something like cache related, or where strong consistency is not the, the most important requirement, then eventual consistency save you time, as well as it's less expensive to operate. So in Cosmos DB, those consistencies are extended into 5 levels. And here from the graph, you see that the higher the availability, the lower the latency, the higher the throughput, then it shifts to the right, which is for a weaker consistency model. But if you want to have stronger consistency where you made the writes and you want to have the reads wherever the application is, whichever the session is using to have the same consistency, then stroke consistency come in place. However, for the most web application development scenarios, what we have in place is actually the session-based consistency model, where during this application session, what application session is priced to the database, it's readily available to be read, and there is no disparity. And depending on how much stronger you need to have your consistency, or you can tolerate some eventual consistency, then you shift the model. And there are suggestions which one to use when, which I'll put into the references of this slide. So next, let's go and look how we can set up and configure Azure Cosmos DB instance. And this is how it's gonna pretty much look like. So let me shift here the gears and open the portal, Azure portal. Oops, restore. So here what we have is currently I'm showing the Azure portal, and here if we go to Cosmos DB, we can see that these are the instances that I'm currently running. And before jumping and looking at existing instances, I want to mention that you may have reservations, which is basically our reserved instances when you are planning to run something for more than a year, or at least a year, so that they will come with some cost savings that you may consider. So this one has its own purchase and view, which you might go and look at that if you look for long-term usage. But in terms of adding a new Cosmos DB account, we are going to click on that. And as you see, it's the same, more or less, view that we have, where we have to set up this configuration. So here, I will just briefly select the resource group, and then we can put the account name. Account name all needs to be lower cases. And for the case of demo, we can say Data SQL Fest 2020. Okay, so it looks like it's not reserved, and this name is a globally unique, meaning that it should be unique across the domain name from where Cosmos DB is served. Then in terms of APIs, we can select the SQL API, which is called Core, then Mongo API, Cassandra, Azure Table, and Gremlin, which is Graph. So we're gonna take the Core SQL, and depending on what you are trying to run, if you are doing some greenfield project and you are interested in the most capabilities of Cosmos DB, SQL API is the one to go. But if you have an existing applications that deal with MongoDB API and you are using protocol number 3.6, then you may go with this version and it will work right away. And with Cassandra and Azure Tables and Gremlins, the same thing applies. So here we select the core SQL API, okay, and then depending on why we are provisioning this account, we can select the production. We can enable geo-redundancy right away, which will take some time, but we can do that later on, and I will show how it could be done. And you may select multi-region rights if there's a need for that. Of course, when we select any enhanced or any advanced features, it's going to have its own cost related with that. So next thing, networking, I want to mention that because it's part of the security. So whichever resource we expose on the cloud, by default, it comes with all networks, meaning that anyone who has the keys and connection would be able to connect to this. However, the preferred way to go is actually to put that into your private endpoint, meaning that you can use the private link, or you can use your own VNet, a virtual network within the Azure, so that only the applications that are allowed to talk to that database instance would be able to talk. And you can define here that you want to be able still access it from Azure portal or not. Usually it's better to put it on, and then your IP address. And for public endpoints, you can define which virtual network you want to put your Cosmos DB in, so that within that virtual network, everything is protected based on the policies that you have within your organization. So for the demo purposes, I'm going to go next encryption. You can use service managed keys, which rotated and managed by Microsoft for you. However, you can introduce your own keys. You can have your own custom managed keys, and then the rotation and its servicing these keys is going to be up to you. Then, of course, we can define tags for easy location and plus billing purposes. And then we can review and create new ones. So and before creation, I want to mention something. Certain locations where you provision that, in our case, the West US, it says provision is going to be 10 minutes. So if we are, of course, I'm currently located close to the East US, so I'm going to select the East US. But even if you selected the region East US and we go to review that, you would see that there's an estimated time, and it's usually in more than a minute. It's 10, 11, before it used to be 5. So depending on which region you are, and it will take some time. Let's click create. All right, so this is how we set the Azure Cosmos DB in configuration and kick the creation of it. Okay, so if you go back to Cosmos DB instances while this thing is getting created, I want to mention certain things because time is we are a bit behind. So here, if I select, for example, this SQL instance, if you remember, I told you that later on there is a way to enable geo redundancy, geo replication. So this is where you do that. So on the overview pane, you can click on it, and then it will ask you, do you want to do this action? Do you want to really enable geo redundancy? And once you say enable, it will take another couple of minutes, to set it up and make it work. But if you wanna, so let me now switch on an instance that already has some provisioned databases, and you can see them through this Data Explorer. As you may see, there are like certain databases here. If you want to look at the overall statistics, in terms of how many queries are there, how it's all going on. So for last 1 hour, I didn't have anything, but within last 24 hours, this is what I got. Then you can look at statistic for the last 7 days, 30 days, and so on. And there's a cost associated with the number of requests and the data, the amount of data that's each database has, so that you can look at your throughput and see how it works. Okay, so while our database is getting provisioned, it's in progress. I'm going to switch back to our slides. Okay, so let's switch back to the slide where we were. So next thing is I want to talk about real world scenario where you want to secure your Cosmos DB, and let's say you need to expose something which is inside your network. You need to expose some APIs to the external customers or at another department within your organization. So in this case, what we see here is actually, so what we see here is, okay. So what we see here is publishing the internal APIs to external customers, where the schema is set it up so that once the code is checked in into the DevOps agent that's running this code, it's going to be deployed to your API apps. And then we have this service in place. Okay. You have this service in place, sorry, which is going to basically where we have API apps that are using data from our internal Cosmos DB, which is provisioned within the virtual network. And as you see, this internal Cosmos DB is not exposed to the external world. It is within the subnet of our virtual network. And then actually, in order to access these APIs, the external developer or external department that we have is actually going through some using the public IP on a managed service, which is Azure Application Gateway, which can act like your firewall. And then it's from there, it's actually giving access to the API management layer from where we are managing them. So in this way, we are basically making sure that the data that we store in our Cosmos DB is well protected, and we are using all the some of the best practices that are recommended by Cosmos DB team. Okay, next let's look at development tools, because we mentioned that. So why we need them? While developing against Cosmos DB, it might be you are going to burn some Azure credits, right? So in order to learn or to give your development team tools and capabilities, not to worry about the expense, the recommended way is to install these development tools. And one of them, you can use your own IDE. It can be Visual Studio Code, an extension for Cosmos DB. Another one is the emulator for Azure Cosmos DB, I'm going to show you, and emulator for Azure Storage and Azure Storage Explorer. So let's look at them. So now I'm going to Storage Explorer. So storage, in terms of where they are and how you can access them, you actually, this is the site. So Storage Explorer, once you install that, it's going to look like this, Azure Cosmos DB emulator, sorry. And once you install that one, you may use that in combination with Azure Storage Explorer, which will have, will look like this. So let me show how they actually look and bring that screen. So when you start the emulator, it's going to appear under the localhost 8081. So I just started that emulator, and I'm waiting for that to appear. Here it is. So once you install the emulator under this given port, you would see this. You would see this information, and then you can explore your databases and what you have there by navigating and looking at them. So this is how it's going to look in your Explorer. In terms of Storage Explorer, I'm going to open that one quickly. This is how it looks like. So it's initializing at this current moment. So while it's getting initialized, I'm going to switch back to SQL API demo here. It's still getting initialized. And I'm going to look at the Data Explorer. So, and we'll look at how to basically navigate and how to write some queries here. All right, so what we have is 3 Cosmos DB databases that are provisioned. And if you look, and the difference that if you want to provision new database on the running instance, first thing that you need to be aware is connection related information. And here under the keys, what you would see is actually the host name where you need to connect, which is URI, and the 2 keys, primary key and secondary key, and complete connection string if you need one. And as you would see, there are read-write keys and there are only read-only keys. And based on your application roles, it's strongly advised, to use either of these keys based on what role the application is using to access the data. Okay, so I'm going to switch back to overview. Okay, and here in Data Explorer, we'll come back to sample DB, and here we'll just look at what we have inside. We don't have too much data under this, but if you look at these to-do items, I think we should have some. So here, how we run the queries, right? So before running the queries, you may initiate one by saying new SQL query and just run it. By default, it's going to give you first 100, but if you want to run, let's say we want to know how many total records we have here under this collection, then we can run our well-known SQL query on a count and say we want to, count of all unique IDs as total count. Okay, and once we execute this, it will tell us, how many total documents currently we have under this database collection. So if you want to create a new collection, let's do that. It's called new container. So when we set it up, it's going to ask for the certain information, and one of them container ID, which is basically you can say it's a container name. If you translate that into the database, relational database kind of notations, it can sound like a table name. And in our case, let's put here, let's say it's a person, and then as a partition key, we need to put something that's actually can easily partition this collection. And in our case, it needs to be something that's, let's say, like a last name. Okay. Okay, so last name, then we put the throughput, and then if we want analytics, we can set it up. I want to mention unique keys. So if you want to make sure that each document within this given partition actually is unique, you can set up your unique keys, and you can read more about that, but it's more about uniqueness of each document, where you want to on certain criteria like last name, first name, and let's say partition name, you want to make sure that that record is unique. So we will say create now, and this is going to add a new container, which is going to be named person or Pearson. Okay. All right. So and then once we have that, so let me switch back to the. So what we did, we just look at how to provision the Cosmos DB instance, and then we looked at the tools. And now I'm going to actually use these tools to show you some examples how to run Cosmos DB with the SQL API. All right. So in order to see that, what we are going to do, let me just quickly switch the view. All right, so we looked at some development tools. Now we are going to look at some demos and utilize the Microsoft Azure Storage Explorer emulator, and then we'll look at security. But before looking into security, let's look at the example that we have here. So in terms of examples that I'm going to show you, they are all actually under the GitHub account that I'm going to share, so you can have access to them. But overall speaking, in order to do, this is a .NET Core app, which is a console app that has actually two projects under it. One's to create the Cosmos CRUD operations, and another one's just simple Cosmos. And under the simple Cosmos, you would see that whenever we create one, I want to mention that we need to add the package for Azure Cosmos. That needs to be added, and plus we need to use asynchronous programming in order to access the database, so there is no blocking while accessing the information. So in this piece of code, what we see is basically we initialize our initial program, and we need to make sure that we supply these two informations, which is your endpoint and authorization key, which we will look shortly. Then we need to make sure that we actually provision the Cosmos client object that's utilizing endpoint and authorization keys. And then we'll just make this call, a wait call to read the account information. And then we'll, handle if there's any exceptions regarding to Cosmos exception, we'll log it accordingly. If there's a general exception, we'll log it and then we'll close the, connection. So let's see. So we need these two pieces of information, as I mentioned, the Azure Cosmos host and unique key. In order to show how it works, I'm going to actually use this emulator account information that we have here. Okay. And what we're going to do is we are going to use this host name, which is your URI. We'll copy paste that one into our host name here. All right. And then for authorization key, we need to use this key from primary key from here. Okay. But in order to, so let's say .NET build, okay, to see if everything is running fine. Okay, it doesn't because we are not in that directory. Let's first log in. So we need to be in simple Cosmos. So we navigate there. Now we say .NET build. All right, seems that it is restored and successful. Next thing we want to do is basically, we know that should work, right? But let's look at the scenario where our local host is defined wrongly. Instead of 8081, we put here 8000, okay? Just for the purpose of to see some errors. And we want to run our application, .NET run, to establish the connection. That's what it does. So in our case, what it should say in the beginning, give us this message. And then if the connection is successful, we should see this read account operation succeeded. In our case, we don't see that. We see base exception saying no connection could be made because of target machine actively refused, blah, blah, blah. So how to make sure that when we get this type of exception, how we handle that is to make sure that our endpoint and authorization key are correct. In our case, when we use our Cosmos DB emulator, this is the correct ones, 8081, and the authorization key. Now I'm going to rerun it again. All right, now we see that actually it succeeded because after this message here, greeting the attendees, we now see read account operation succeeded. And at the end here, we see end of demo, press any key. So basically, this is the simplest thing that we can do. And I want to start from there because this shows us how to create the Cosmos client first. And then what are the endpoint and authorization keys here. It also gives us the idea about using this asynchronous method to read the account related information or any other information from Cosmos DB, and plus how to handle it in terms of using this Cosmos exception related, how to handle Cosmos exceptions, and as well as how to handle the base exceptions that we can get. Okay, so this is the simplest thing we can do. Now, before switching to the CRUD operation, I want to switch back to see where we are in terms of time and slide we need to move for. So let me show the security and then we'll look at the second application, okay? So here in security considerations, what we see here is actually what we need to take into account is the keys that I just showed you. There are primary key and secondary key, and there's a read only, read and write, and just read keys. There's a resource token that are created for each resource that we need to be aware. And plus we need to use the private endpoints, firewalls, and advanced security, which is in preview, that would give this extra level of protection to our database, which is most valuable assets. And to see them in the portal, I'm going to switch to the portal. All right. So here under portal, does everybody see the screen, by the way? Hello?
Yes, we can see it.
Great. So here in terms of security, I want to mention it because it's very important to protect our database. And from Cosmos DB, you can enable virtual network, select the networks that you want to provide access to. And here you would specify your IP range, and as well as, do you want other Azure related service access it or not? Okay, so this is the place where we set it up. Second thing is a private endpoint connection, which is something that if you want to provision if you want only certain services, Azure services, like, for example, you have your Azure web app and you want that Azure web app using this private endpoint connection connect to the Cosmos DB so that no other service is able to access it, then you can set this private endpoints. In addition to that, there's a way that you can go ahead and provide this information to Azure Security Center. So what is that? The Azure Security Center is basically a general hub that will collect all these security threat related informations that are gathered within your Cosmos DB instance, and it will give you this advanced alerts and triggers, and plus information to analyze regarding, is your database under attack, or is there some malicious activities are going on. So these are the even though it's in preview, but these features are very important to be aware about. Okay, in addition to these security features that I just mentioned, you can also utilize these activity logs where you can navigate and see what happened. And you can, for example, define the time frame and then see, what type of activities happened with your database. Was there any, updates? What type of information was there any backup, listing key? So you can get all this information from here. Okay. So now switching back.
Hello, Elkhan, can you hear us? We
Hello,
cannot
yes.
hear you.
Yes. Sorry. Thank you for reminder. I was in a mute.
Yep.
What I was saying is that we just looked at the security related information, and now I mentioned the best practices that we need to take into account, and I will have the reference in my presentation that's going to be uploaded today to these resources so that you can get more up-to-date information. Now I'm switching back to the demo where we are going to use CRUD operation on Cosmos to see, how we can to get basically more information about real world usage of this Cosmos DB. So in order to access that, I'm going to use the here it is. Let me know if you see the screen, if you don't see it. So I'm going to navigate to the folder Cosmos CRUD, and here we are there now. What we have inside is we have I'm going to walk through very fast because we have less information. So what we have here is that we need to define endpoint and primary key as you learn. And then through the main program, what will happen is that we define our database and its container name. Then we'll initiate the instance of the program, and then we'll try to uh, start the demo here. So when we go to the definition, you will see that what we have under it is basically we're gonna learn, we're gonna get how many task numbers. So before speaking about this small demo, let me mention that this is a to-do task. What we do here is basically we set the properties for our to-do document, which has ID, message, category, creation date, and is it checked or not. Okay. And then for this document, we are going to create a database called to-do database with the container name my items. And then here we are going to get the number of how many tasks we want to create. And then we'll initialize database as well as container. We will set this category currently manually here. And then we actually going to add these items to this asynchronously to this method, okay? And then we'll read them. That's what it does. And if you navigate inside of these functions, you will see what they are doing. But in terms of time and, I'm going to run it right away. So as you see here, let's go back and look at it. So it's going to run on this instance of SQL API demo 2. So what we're going to do is actually, I'm going to go to that instance here. And for this my items, we see that we already have information. So I'm going to actually delete that for now. And the reason why I'm deleting that is to make sure that, when we create new one, actually it's going to populate new one. So it's live demo, okay? So I'm going to delete this container, which should remove that one, which is gone now. I'm going to switch back to the application, and let's first build our app, and then we'll run it. So what happens now is it's going to ask how many tasks we want to create. And each task that we create are going to be created under the category, predefined category July tasks. So I'm going to tell, let's create 200. The interesting thing here is that while it's getting executed, it will first check the database and create one if it doesn't exist. And if container doesn't exist, it will create the container, and then it will actually list them all together. I want to mention something here while execution happens. As you see, when each message is getting created, it's consuming certain RUs, which is request units. Okay, what is that? Request units are basically this throughput that or power. It's a combination of CPU, I/O that Cosmos needs in order to make this operation. In this case, it's actually 6.86 RUs. Okay, and why we need this thing to set it up, because while you're setting your container, you have to set it up. So while we know that this operation went successfully and we need to check it, okay, so we go back to our container and refresh this. All right, and then we see that it's back here, my items, and these are the things that we have. If we run the new query, these are the items that have been created. And then we can run our, filters in order to see how many here. And in our case, it should be, let's see, how many do we have? Count, see that. I made a typo. As total. All right, let's run this query now. Okay, we have 200, created. So I want to give some time for Q&A before finishing this, but to wrap it up, I want what we did basically. We looked at Cosmos DB, what it is, what this Cosmos DB engine provides. Then we looked at managed databases under it. We looked at consistency models. We looked at configuration, how we can set the configuration at the point of provisioning. We looked at some development tools, and then we moved into demos where we looked at simple connection as well as the CRUD operations. Then we looked at security considerations that we need to take into place whilst putting our database into the cloud. And then we looked at onboarding best practices that are going to be in the reference. And now that's it. So what does Cosmos have to do with the database anyway? I would say it's just Cosmic scaling the database and taking care of the concerns of operations is a big plus, but we need to be aware how to set it up and how to manage it appropriately. That's all on my end. Thank you for coming. So you may feel free to connect with me on LinkedIn. This is where it is. I'm going to post the code and slides under this GitHub account that I have, and feel free to connect with me. Thank you. So any questions that you may have? We have 5 minutes left.
Yeah, we do have just a few more minutes. Thank you, Elkhan. Knowing that we started a little bit late, and again, our apologies for that. But yeah, we are here for a few more questions.
All right. So in terms of cost, right, I see there's a cost-related question. So in terms of cost, I would say that the cost is directly related to the RUs that you use. So as you see here, I'm going to show you lively. So depending on how much RUs you have and the data, how much data you have, this cost is going to, vary. And by default, when you set it up, you would see that for 400 RUs, it's a daily cost like 0.77 cents. But that RUs and everything needs to be careful. If you look at the best practices, it will tell you, how to set it up. But roughly speaking, when you have 1 kilobyte of document, okay, and you want to query that, it's going to require a 1 RU. But if you want to write down 1 kilobyte document into your database, it's going to take 5 to 7 RUs. Okay, and that's something that you need to be aware. And let me show you actually some Data Explorer. So
yeah, and
yes.
I just want to mention there is another session starting in 5 minutes, so probably just 2 minutes because we need to prepare for. Sorry about that, but we need to.
All right. Okay. So if you have any questions, guys, feel free to connect with me on LinkedIn. Ask the questions there, and plus, put any challenge that you have. I'll be very glad to, address them. Thank you all. Thank you for attending my session. Bye.
Elkhan, thank you so much, and we'll post as well the recording. Thank you, everyone.
Thank you.